This is session number 5 for NTP. We are going to see troubleshooting commands. We are going to include the show clock command, show NTP status, and show NTP association. The most basic command that we can use in order to see how NTP is behaving is show clock. Show clock will give us the time and date. What we need to do with this output is looking at the first character at the beginning, looking for a special character. It may be a dot, it may be an asterisk. If it is a dot, that means that we have exchanged packets with a peer or server, but the clock has not been synchronized yet. Most of the times we only need to wait, because NTP takes some time in order to synchronize a clock. It may take several minutes. On rare occasions, if it is taking too long, we might need to troubleshoot this case further. If it is an asterisk, that may be because of two reasons. Reason number one, we have not configured an NTP server or peer yet, so the resolution will be configuring at least one. Reason number two is that we have not received any packet from the NTP server or peer that we have configured previously, so we will need to troubleshoot this case further. Now, if we don't see any special character at all, that is a good sign, because that will mean that the clock has been synchronized with an NTP server or peer. Okay, the next command will be show NTP status. Show NTP status will provide us several statistical values for NTP. For instance, dispersion. Remember that dispersion is an estimated error in the measurement of time since the last packet was sent. In this case, we see the peer dispersion and the accumulated dispersion to the authoritative time source. This value can start high. The highest value for dispersion is 16,000 seconds. However, this value should decrease over time as NTP synchronizes. The values being shown here seems to be good as they are low. However, if you continuously see 16,000 seconds or a value around that continuously, that is a bad indication. Next, we have the accumulated route delay. This is the round trip time between this device and the authoritative time source. Since most of the authoritative time sources are located over the internet, this value seems to be fine, because we need several milliseconds in order to reach anything over the internet. Then we have the clock offset, which is the estimated maximum offset between the current device's clock and the server's clock. If we see a value greater than 0, that will mean that the server's clock is running at a higher time than the current device's clock. If we see a value lower than 0, that will mean that the current device's clock is running at a higher time than the server's clock. And we can see also whether the clock is synchronized or not. We can see the current device's stratum. If we saw here a value of 16, that would mean bad news, because that would mean that we are not exchanging NTP packets correctly with our server or peer. Next, we can see the IP address of our server or peer. In this case, we can observe that this is an public IP address, and given the current device's stratum is 2, we can reach the conclusion that this is a public NTP server located over the internet that has an stratum of 1. Then we can see how our hardware clock is behaving. The nominal ideal frequency of our clock is this. However, NTP is reaching the conclusion that it is running at this frequency. Then we have the precision of our clock given in seconds. The way to read this will be calculating 2 elevated to the minus 10th power. Lower is better, so if we saw here 2 asterisk 18, that will be a better value. Then we can also see how often are we polling the server. In this case, we are polling the server every 512 seconds. This is a good indication. This means that NTP is stable, it is synchronized, so it does not need to be polling the server too often. The minimum value will be sending one poll every 64 seconds. 64 seconds is the minimum value for CISCO. When trying to synchronize, NTP will be sending packets at this rate because NTP is trying its best in order to gather enough information to synchronize as soon as possible. The maximum value will be 1 pole every 1024 seconds. This is the maximum value. If we saw that, that will be a bad indication, because that will mean that NTP has given up trying to synchronize with the server. And in this case, we can see that the last poll that we sent to the server was sent 491 seconds ago. Okay, the next command is show NTP associations. However, before moving on, in order to talk about the detail of the output of show NTP associations, just a note here, there are some pieces of information that get repeated with show NTP status. For instance, the peer dispersion, the clock offset, the pole interval, the address of the peer or server. Now, the delay is not repeated because we can see here the root delay. However, the command show NTP associations shows us the peer delay. First, let's take a look at the second character. If this character is this one, that means that we manually configure this peer or server. Remember that when using broadcast, servers are discovered automatically. Next, we will have to take a look at the first character within the output. This character may change over time. It may start as a plus sign. That means that this peer or server is a candidate to get synchronized with. This may change into a pound sign. That will mean that we have exchanged NTP packets with this device and we are in the process of getting synchronized. Then this may change again into an asterisk. That will be a good sign. That will mean that we have successfully synchronized with this peer or server. Okay, then we have the IP address of our NTP server and the stratum of our NTP server. We can also gather the IP address of the server of our NTP server. So let's say that we are sitting here in this device executing show NTP associations, and this device has this NTP server. So we will see this IP address here showing us that this is the IP address of our NTP server with this stratum number, and we can gather the IP address of the NTP server of our NTP server. Okay, let's talk about the next couple of values within the output, the when value and the poll value. Now, the poll value is going to tell us how often are we going to be sending poll packets to the server. So in this case, we are sending one poll packet every 64 seconds. The server is going to eventually respond within a couple of seconds afterwards. So we are going to be receiving packets from the server, let's say every 65 seconds to 68 seconds, just to put an example, roughly, because after sending our poll packet, the NTP server is going to respond back. Now, the when value is going to tell us how many seconds have elapsed since the last time that we received a packet from the server. So if you issue the command show NTP associations repeatedly, you will see the when value increasing over time. It is going to increase to a value slightly larger than poll, and after the server sends back the response, it is going to get reset to 0. Next, we have the reach value. This is an 8-bit circular buffer that represent the last 8 packets that have been received from the server. It is given in octal, so in order to make sense of it, you might want to translate it to binary. So the idea behind it is that you want to see a value of 377 most of the time. That will mean that you have received correctly the last 8 responses for your polling to the server. If you see a number different than this, that will mean that you are losing some responses. And so this represents the health of the communication exchange between client and server. Then finally we have the peer delay. This indicates the round trip time in order to reach the peer. Then we have the clock offset, and then we have the dispersion. As we commented previously, this value will be high at first. The highest value is 16,000 seconds. You want to see this value getting lower as time goes by. It should decrease over time, and you don't want to see this value stuck at around 60,000 seconds.